In our case, the output is whether somebody is going to buy a computer or not buy a computer. But there are four influencing variables: age, income, whether somebody is a student, or what is the credit rating. And then what we try to do is we try to identify if we, for a new data item, if you get a new data item, we have to identify what should be the output. So the new data item we get is X is age less than 30, income is medium, student is yes, credit rating is fair. So for this, we want to identify whether somebody is going to buy the computer or not buy a computer, because these are the two output variables, right? So for that, we try to identify for that data item, age less than 30, we find out age less than 30, then what is the probability of computer buying, given that observation is computer equal to yes. Same way for that data item where income equal to medium, what is the probability that income equal to medium given computer buying equal to yes. Then we multiply all the four corresponding data item related conditional probabilities, and we find out the probability of this particular data item being leading to computer equal to yes or computer equal to no. And what we find out is that the probability of computer buying equal to yes is 0.028, and probability of computer buying equal to no becomes 0.007. So we assign this particular new row, which is the set of values which we have observed, to buy computer equal to yes. So that is the class we are assigning to the output variable here. So why I wanted to go through this is because when we're doing with the data set today, we will look at how you can compare two different algorithms, not just one. So now, having equipped with two different variations of supervised learning algorithms, let us go to Weka tool. So please open the Weka tool. You should get something like so did you get the Explorer? Rajat, could you get a screen like this? Now we'll go to Explore. Open the file in your data directory, which is inside Weka. Open CPU. So as we saw in earlier examples, when we work with a supervised learning algorithm, there is always this notion of class variable. Class variable is the variable which is defining your output variable. It could be one of the classes which you will be working on. You will have to take the input data, and then you have to look at what class the data is going to fall into. So the input data, you're already labeling them in terms of specific classes. So let's look at the data file for a moment. Let's go to the directory. let's go and open the CPU file, AIRF file, open it with maybe Word or Notepad. So this is basically a set of data items related to the different variables we're talking here, which is basically MICT, MIN, max, CH cache, CHMIN, CHMax, etc. So you see here, it's basically looking at the data from a perspective of what is the set of input variables. Then we have description of the class variable also, which is a numeric. Then we have add data and we have encoded all the observed data. Clear? So this is the way typical data set which looks, which is given to the learner. So when you get a raw data, there's some amount of pre-processing you have to do, which is what we would be interested in when we take a new data set. You label the variables and then you bring the type of the variable. In this case, it was numeric. So now, since you have loaded the data, what we will now do is we will try to classify this using a linear classifier. Go to classifiers, functions, simple linear regression. And then let us follow the cross validation method because that's okay. Or let's take percentage split, like I said, right? You can take, let's say 80-20 kind of a split. And let's say, let us start building the model. So what we have done is we have created a linear classifier for all the data items. And what we found is let's go back to, I think there's some problem here. Let me go to so what this is saying is we are trying to get a model in terms of only one variable. It's not getting influenced by others. It's surprising. Did you guys get the same result? The equation that you got is very surprising. It shows that the influence of other variables is practically nothing. So let us visualize the data. So class with no, that is visualization. What you works with is visualization, but the classifier should be generic. It's surprising. Let me look at okay. Yeah, so I think what we did is we took simple linear regression, which works with only two variables. Let's go to linear regression, not simple linear regression. Got it? So once you go and work with a simple linear regression, this is a far better. So now you could see that there is a equation of the form which is a straight line, right? Which is a equation which we got. Now this is typically the line which is going to help you visualize what is it corresponding to each. Since we're talking about a multi-dimensional thing, it's very difficult to visualize, but you can look at how the class variable is changing with respect to each. You can change each of the input variable and you can look at what is the dependence on that. So could you get the idea that now you're talking about classification with which is going to give you a linear equation in terms of the individual variables here. Now, while we do this, let me take one step ahead and let us try working with data where necessarily the variables. Yes, so linear regression is not very good. It's very high. So let us do one thing. Let us choose a Bayesian classifier. Bayesian won't be applicable also for this. Yeah, because Bayesian takes into account frequency, right? Frequency of each kind of data. It's not working only for all continuous variables. No, I don't know any other thing on which you can work on this. So I guess the other option is we can look at getting an SVM, but unfortunately SVM is not working right now. Yes, but we have not been able to do that because there's some issue compatibility with JVM. We'll do it in some at later class. I'm trying to see if there is a way by which you can do this any better. I think because all are continuous, I cannot use a Bayesian. Okay, let's take so let me continue my lecture with let's open another file. Let us say we open a file like CPU with vendor. And then what happens is, in this case, you have to find the difference is that this particular variable vendor is not a continuous variable. It is a discrete variable in the sense it has specific values like advisor, Apollo, Burrows, CDC, AMDAL, etc. All other variables are continuous. So here when we run a classifier which is based on linear regression, then you start. You got this? This is a very interesting combination. So I'll help you understand what this means. So for the continuous variable, it was very easy to create something known as a straight line, right? But for the discrete variable, there is a specific syntax this kind of equation throws at you. It says, look at your data and see if you have a variable vendor equal to AMDAL. Then for this particular data item, you will substitute it with 1. It becomes minus 51.2 into 1. Same way here in the second one, 176.52 times AMDAL is at second position. So you have to multiply it with 2. Same way AMDAL is here at third position. So it will become minus 1.3.6 into 3. And suppose if it does not have AMDAL, then it becomes 0, that particular coefficient. And then you add the other continuous variables. So this is a very interesting way of discretizing, making a continuous variable out of a discrete variable. So what it does is it looks at the different combinations of data that exist, tries to create relative influence of combinations of data which are present. So let's take example of vendor equal to CDC. Let's look at if it's there in the first one. It is there somewhere here, right? I think 21st or 20th or somewhere. So here we'll say minus 152.76 into 24. Then you look at CDC is present here. It may be slightly less, maybe 19 something. So you'll say 141 into 19. Same way in this, for example, you don't have anything. So it becomes minus 41 into 0. Like that, you continuously add depending on the data that is present in your data set. For that row, depending on the value, you will calculate the value of the corresponding output. Is this clear? Because this is a very unique way. In fact, each tool has its own way of handling when you're mixing discrete and continuous variables. So this is one way they try to bring in this notion of continuity into a discrete variable. Is this clear? This is something you will encounter whenever you're talking about a mixture of continuous and discrete variables. I'm just trying to see if there is any other way you can we run a decision tree? No. So the numeric values are arbitrary, means you're taking meaning the output curve. These are generated by the algorithm. This is one way of looking at a potential classifier for your data. It is generated by going through the potential combinations and then it throws what is the maximum best possible line that can be created. You don't generate this. This is generated by the underlying curve fitting algorithm. So as I said, you can save this model. Yeah, the computer example values is more or less the coefficients which are fixed for each variable. There's only one coefficient because it's a continuous variable. In here also same thing, right? If you see cache and min and mmax, the coefficients are fixed. But you got to understand that this is something which it has found from this particular sampling. Let us look at if we change the sample. Let's say we talk about 90-10 percentage and you want to start. Will it get, just remember 0.0616 was, so it's not changing the equation. Pretty much it is giving the same dependence upon the variables. So that is a good thing. It means it's not so much varying with respect to the change of your sample. So that's a good robustness of the equation you found. Or let's do cross-fold validation, tenfold validation. Even then the equation is not changing that. Got it? So it is very important for us to understand that when you have discrete variables, it is not an easy task to work with. If you have to work with something like a linear regression, you have to do approximation like take combinations and create what are the different combinations that exist in your sample set and create something like this. Same thing will happen in other tools also. All tools have their own way of writing it. But the way you got it is, it's basically a way of approximating continuity for the discrete variable. So while we are, yeah, so in some cases you cannot avoid because you don't have other algorithms which can work on it. This is the kind of data which is very scattered, very difficult to do any other algorithm on this. So one way you can do is maybe you may want to change your data set by doing some trimming off edges, in sense trimming off very extreme values and then rerun this model. So that is what is exploratory data analysis. So it's not like you'll always get a perfect fit, but you have to live with it. In some cases,